All right, everybody, we are going to be dealing with the number system today. So let's see what we got going on. I see rational and irrational numbers. Oh, vocab here, okay. I see more radicals, okay. Repeating decimals, radicals. Damn, radicals. All right, so, whew, this one, I get the struggle, guys. All right, I'm gonna try to make it as simple as I can. All right, which is the same setup I've always been doing with you guys with the radicals, and it tends to work out pretty much all the time. Okay, so let's see. Enter a fraction equivalent to point or 0.4 with a little line on top. I should know what that is. I should Google it. Anyways, next time. Use only the whole numbers for the numerators. Oh, they gave me a very specific hint. They said use whole numbers for the numerator and denominator. So essentially, I need a fraction, right? With the number over a number. And it looks like I can't use a calculator. Wait, can I even use it anywhere? Damn, no calculator today. Okay, all right, it's all right. We got this. All right, we got this. So here's the thing. It's a shortcut, right? I don't even know how else to explain. This is one of those things you got to know. All right, so what happens with a repeating decimal? Well, if it's one number that's being repeated, we're going to use that number on top, right? So that's the number that repeats, and you put it over 9. That's it. That's all it is. And I know I can't use the calculator, but I'm going to prove it to you. Right, here's my state exam calculator. So if I do 4 over 9, do you see how it keeps repeating? So let's say it was 2 over 9. So guess what number it's going to be? Let's see. Where is it? So 2 divided by 9. You see how it's 0.2222222. If I do 3 divided by 9, it'll be 0.33. You see that? The thing where it gets crazy is what if it's 0.12, 12, 12, 12? Well, the 12 repeats, so I'm going to put a 12, and instead of a 9, because there's 2, I want to put 2 9s. So let me show you. So 12 divided by 9, that doesn't work, but if I do 99, oh, look at that. So it's a nice little trick to know. I never would have guessed they would have this on the state exam, right? But there it is, okay? So it's a nice little shortcut for you guys to kind of like understand, I guess. So my fraction is 4 over 9. All right, calculator away because I can't use it. Determine whether each number is rational or irrational. So again, vocab, rational is a number that repeats or stops, okay? And by repeats, it also means it has a pattern. So like 0.22222, do you know what number's after? You do, right? And irrational is easy. Never ends and no pattern. Like you don't know what is going on. So what usually happens is your irrational number is going to be a radical or it's going to have pi. That's essentially it in middle school, okay? And what I mean by radical is you can see radical 16. Radical 16 is actually perfect because it's 4, right? This is 4 times 4. So since the value is 4, that number stops. It's rational. But if I get square root of 8, square root of 8 is not perfect. So because it is not perfect, that means it's irrational, automatic, okay? 3.68, it stops at 68. So again, it stopped there, so it's rational. Pi over 5, I told you, if there's a pi attached to it, it makes it irrational. And then 1 over 4, you should hopefully know, is 0.25. You get it 1/4. You get it? You get it 1/4. So that makes it rational, okay? So usually what happens is this one, you just have to divide, okay? So if you forgot, it goes like this. Numerator on the inside, denominator on the outside. So 4 goes into 1 0 times. It's times 0. So if I add that, that's 1. Bring down to 10. So now that's 0.2, that's 8, subtract, that's 2, bring down to 0, that's 5, and that's 20. So that's 0, so you're done. So see, 0.25. So if you get a fraction and you don't know what it is, you just divide it, right? That's a skill you should have picked up in elementary school. We don't use it that often because we have awesome calculators, but like I showed you here, it's nice to still know it. All right, so let's see, true or false. And here's the skill I was talking about earlier. What should you know? Square root of 1 equals 1. Square root of 4 equals 2. Square root of 9 equals 3. Square root of 16 equals 4. Square root of 25 equals 5. Square root of 36 equals 6. Square root, let's see, 7 times 7 is 49. 8 times 8 is 64. And then 9 times 9 is 81. And then 100 is 10, and I'm going to stop there. And I'm going to use this. This is just nice to have for the rest of this little quiz here, right? See if it's helpful. So why am I doing this? Because if I have 4.1, I know what that is. Square root of 20 is somewhere right there. So if I put square root of 20, it is almost smack dab in the middle, right? Because to get there, it's plus 4 from 16, and it's minus 5. So you see how it's almost the same distance. So this is around 4.5-ish. 4.4 maybe, because it's closer to the 16. Okay? But either way, it is still bigger than 4.1. That's where this is really nice to have, right? It took me less than a minute to write, right? Just because it's a pattern. But it's going to be super helpful in the long run. All right? So let's try the next one. 8 is less than or equal to square root of 60, or square root of 68. So square root of 68 is after, right here. So that's square root of 68. So that means it's 8 point, let's see if it's 4 away, 7, like 8.3, 8.4. Either way, it is bigger than 8. So that's also true. And the last one is annoying. So I'm going to delete that because I'm going to probably use it after. So let's see. Last one. What do we got? Square root of 80 over 2 is smaller than 3.8. Well, square root of 80 is right here, no? So that's basically like 8.9 square root of 80. Okay. So if that's 8.9, that's basically 9. Okay. So what's 9 divided by 2? That's 4.5. Is that smaller than 3.8? No, that's false. Okay, and even if it wasn't 8.9, like if you can cut 8.9 or 8.8 in 2, that would have been 4.4, which is still bigger than 3.8. So that would have been false, right? So it's not that bad. All right, so enter the approximate value of 2 radical 5 to the nearest 10th. So here we go again. I got 2 times radical 5, or 2 times, well, what's radical 5 here? Radical 5 is in between radical 4 and radical 9. So if I think about it, the distance from here to here is 5, right? So if I say radical 5, that is 1 away from my radical 4. And it's 1 out of 5. So that looks like it's going to be 2.2. Because 1 out of 5 is 0.2. So that's my rough estimate. It's an approximation. So if I do 2.2 times times 2, what is that? 2.2 times 2, that gives me 4, and then 4, 1 decimal place, so 4.4. Okay. And let's see how close I was. And again, I can't use the calculator, but just to double check our work. Okay. So let's clear that 2, and then radical 5. Hey, look, 4.4. This one would have been 4.5. So close enough. Okay, that's an approximation they should have given you if you're within a tenth. So I think they would have been happy with 4.4, 4.5, and even 4.6. Okay, you should have been okay. All right, number 5. Now we're going to add them. So this is where it gets annoying. Choose all the expressions with a value more So it has to be bigger, 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 bigger than 6 plus radical 3. So here it is again, radical 1, radical 4. So there's radical 3. So notice, if I go, this is 1 and this is 2. So this is basically, there's 2 spots, right? So I'm going to say this is going to go from 1 to 4 is plus 3. So if I go 1, 2, that's 2 out of 3, which is roughly 0.67. So I'm going to say this is 6 plus 1.67. So that gives me 7.67. So it's 2 pi over square root of 5 bigger. Dude, these are annoying. Like, that sucks that they want you to know this. Okay, so hopefully they're easier. So let's see, 2 times pi, and I'm going to estimate here. Okay, so something you should know, pi is 3.14. Because again, there's no calculator. That sucks, right? So we got to do a lot of chicken scratch work, as I like to say, which is just a bunch of just number crunching, all right? So let's do the first one. So 2 times 3.14, or times 3. And then radical 5 is right there. So it's like 2 point something. So I'm going to say 2.2. Okay. So that gives me 6. And then if I do 6 and I divide that by 2, because again, I'm estimating, it's really close to 2, right? So it's 2.1, 2.2. It's really, really close to 2. That gives me 3. If I had changed it to 2.2, it would have been even smaller. Remember, my whole number is basically a 7. So this one is not bigger. So let's do the other one. So 25 over square root of 5. So square root of 5 we said was like 2, right? Well, that gives me like 12 point something. 12.5-ish. So is 12 bigger than 7? And see what I'm using? I'm using the whole numbers, right? Yeah, 12 is bigger than 7. Let's do the next one. I got 4 plus square root of 6. So square root of 6 is here, square root of 7, square root of 8, square root of 9 is 3. Right? So again, I'm going perfect, perfect. And if I got square root of 6, it's 2 down. It's kind of in the middle-ish, okay, because there's 4 in between. So I'm going to say that's 2.4, okay, maybe 2.5. It's not 3, right? If I had said 4 plus 3, which it's not because that's square root of 9, that would have been 7. And this one is 7.67. So, yeah, that's not bigger. Okay, it's smaller. Okay, which is less than 7.67. And my last one, think about it. If one of those is correct, the other one, there should be at least 2 or 3. So I'm guessing the last one's going to be okay. So let's double check. I got 10 minus 8 over square root of 10. Well, what's square root of 10? Square root of 10 is right after 3. So I'm just going to say divide by 3 because it's really, really close. Okay, there's like 3.1 or 3.2. Okay. Well, how many times does 3 go into 8? 3 goes into 8 around 2 point, what is that, 2 2/3, which is 2.67. So 10 minus 2.67, that ends up being, yeah, that's really close. Because that ends up being 7.333333. So that one was a tight one. And that one is, no. So I did this one wrong. That one does not work. Okay? Because that's actually smaller. Let's see, 10 minus 2 is 8. And then take away 0.67. Yeah. So only one of them worked. It should have been 2 or 3. And again, on the state exam, it will be 2 or 3. Again, I made these up, so you can see how annoying they are, right? Just to work them out. Imagine trying to come up with these. So that was crazy. Okay, let's try these. This one I've seen a lot in your other examples, especially in the interim. So let's see what they want you to do. I got 16 plus 5 plus 20. So that gives me, let's see, 16 plus 5 is 21. 21 plus 20 is 41. So that's in between square root of 36, which equals 6, and square root of 49, which equals 7. So from here to here, it's plus 13. But if I got to go to 41, from the 36, it's plus 5. From here, it's minus 8. And the reason I want to show you that is because what would happen if it was smack dab in the middle? Then it would be 6.5, right? But it's closer to the 36, so it should be closer to 6. So can you see what my answer is? 6.3 and 6.5. All right. So here's another one, square root of 80. So let's see, I got square root of 81 is 9. And because it's 80, I want square root of 64 is 8. So this one belongs somewhere down there. So it should be 8.9-ish, or in this case, closer to 9. So not that bad. Okay, these aren't horrible. This one, oh my God, this one sucked. Okay, so just be patient with it. You can see a lot of these questions are not that horrible. Okay, when it's just like individual, right? All we got to do is just kind of set it up this way, right? The way we've been doing before. So here's another one, very similar. So what does that give me? Square root of 49 minus 16. Let's see. If I take 49 and I take away 10, that's 39. Take away 6, that's 33. 33 plus 9 is 42. So I got square root of 42. So what does that give me? Well, that's square root of 36, and there's square root of 49. Was that the same thing? We literally just did that right here. Okay. But now I want it at square root of 42. So square root of 42, it's 6 away. And if I go down, it's 7 away. So it's almost smack dab in the middle. So is it closer to 6? No, it's in between 6 and 7. Okay. All right, which number is a close approximation to, be careful, cube root? So this is where it gets crazy. 360 cube root, that means what number times what number times what number equals 360. So it has to be the same number. So think about it. 120 times 120 times 120. Yeah, that's not even close. 180 times 180 times 180. There's no way. And then 90 times 90 times 90. Yeah, so my only option is 7. Okay, so 7 times 7 times 7. And think about it. This is 49 times 7. So that gets me pretty close. And if I eyeball it, let's say that's 50-ish, right? 50 cents. So 50, 50, 50, 50, 50. What is it? 1, 2, 3, 4, 5. Plus 50 plus 50. There's $1. There's $2. There's $3. $3.50. Yeah, that's close to 360. So that's how I eyeball it. Okay. All right. Here we go. Now I think these are going to be way easier. Oh my God, super, except this one. Oh, not that horrible. But these are going to be easier. Okay. I got square root of 36 plus 9 is 45. It's the same thing, but round to the nearest 10th. So let's see. Square root of 36, just for practice. Square root of 49. So if I got square root of 45, I went how much? That's plus 9. This one, I went minus 4. So it should be closer to the 7. Okay. The question is, how do I figure it out? Well, to go, the total distance is 13. So how far did I go? I went 9 out of 13 spots away. Do you see that? And the way I want you to think about it, if I was smack dab in the middle, I would have said like 5 out of 10. Well, 5 out of 10 is a half, right? So that's 0.5. So that's a good kind of approximation. What's 9 divided by 13? I don't know. But if I did 9 out of 12, that's 3 out of 4, which is roughly 0.75. So see, I'm just estimating, right? So in this case, you know what? I'm going to say, because it is past the halfway point, right? If it was in the middle, it'd be 6.5. I'm going to go and say 6.8. Okay. And let's try this out just to double check. And again, you can't do it, but let's see if our strategy is working out. And they should give it to you within 0.2. Okay. So if I clear that, square root of 45, 6.7. Okay, so I was within 1/10, and usually the state exam will give that to you. Again, you are approximating. If you had said 6.2, you're wrong. Okay, but 6.8, it was one decimal, right? 1/10 away from 6.7, so that's okay. If you had said 6.6, they would have probably given it to you too. All right, so let's keep this open, even though we can't use it. Okay, but let's approximate. So same skill. All right, so let's see, 72. What is that close to? I know square root of 81 is 9. So then the one below is 8. So 8 times 8 is square root of 64. Where's square root of 72? Square root of 72 is somewhere down there. So from here to here, it's how far away? It is 17. Okay, that's the distance. So how many spots is 72? So 72 going from here to here, it's, what is that, 9 away. Going from here to here, it's 8 away. Hey, it's almost smack dab in the middle. So which one should it be? This one's a tricky one. Which one is it closest to? So in this case, it is closer to the 8. Okay, so is it 8? It has to be less than 8.5. So let's check it. Square root of 72, 8.48. It was by 0.02, guys. That's how close it was to the 8 as paired as the 9. And normally they wouldn't do that. They would probably say, oh, it's 7 and 9. But I think I was trying to be like super tricky with you guys, see if you got it. All right, here's another one. And you can see, look, 3 and 4, those are close together. 10 and 14 are kind of close together. So let's see what this equals. Square root of 20 minus 8 plus 12. So 20 minus 8 is going to be 12. 12 plus 12 is 24. So I know that square root of 16 equals 4. Square root of 25 equals 5. So to go from here to here, it was 9 away. But I have a square root of 24, which is right here. So that should be really, really close to 5. So that's B. Easy. I don't have to really think about it right there. All right, here's another cube root. So notice the numbers are smaller now. So what times what times what gives me 60. 7 times 7 times 7. We already said it was 300 and something earlier, right? So that can be it. 4 times 4 times 4. Let's see, 4 times 4 is 16. 16 times 4 is 24 to 64. Yep, that's it. Okay, it's B. 8 times 8 is already 64, and I have to multiply times 8 again, and then 20 times 20 times 20 is not even close. And our last one. So let's see, true or false. And again, it helps to have, let's see, I have square root of 40, 49, and 48, and 80. So square root of 36 equals 6. Square root of 49 equals 7. Square root of 64 equals 8. Square root of 81 equals 9. And again, I'm doing this over and over and over, but it took me less than a minute to set it up, okay? It can be a little tedious for you guys, but it's good practice, okay? Plus, it helps you remember your perfect squares, all right? Don't be lazy. I always tell my kids is do not be lazy. The setup makes your life a lot easier. Watch. So here's what I'm talking about. 20. Where's square root of 40? Square root of 40 is somewhere right here. So it's supposed to be between 6 and 7. 6 point, what is that? I don't know, 5, 3, whatever. 6 point something. Is that bigger than 20? No, that's false. See how easy we just made it? So square root of 49. Square root of 49 is exactly 7. Is 7 smaller than 7? No. So if there's two no's, the last one, if I did this correctly as a teacher, should be true. So let's see if I made that true. Square root of 80 is right here, which is basically 9, right? But it's not. It's 8.8, 8.9-ish, because it's less than 9. But see how it's really, really close to 9? Why do I care? Because if I say this is 9-ish, because I was off by point, right, 1. So 9 divided by 3 is just 3. Is 3 smaller than equal to 4? Yes, 3 is smaller. So that's true. So again, all of this right here, it makes our life a lot easier. Okay? And you hopefully realize most of these were not that bad, right? The setup is always the same. You're comparing, you're trying to guess where it is. What two perfect radicals is it in between? The only one that sucked today, let's be honest, is this one's not that nice, but it wasn't horrible, right? This one sucked. So this is one of those that's like level 3 versus level 1s on the other ones. Okay, I think this one's crazy. All right, so that's it for number system today. Until next time.